Okay, so thank you for coming to our talk. Less waste, less work, using VM like time for resource cleanup. I am Nisha and he is Kuroha and we come from Japan, LY Corporation. Quickly starting with our basic introduction. So this is my photo from last year's summit in Asia, in South Korea. And I've been working at LY Corporation, which was former Line Corporation, for past 3.5 years. And I mostly work on developing and operating large-scale OpenStack-based private cloud. I have previously contributed to Ironic and currently trying to contribute to OpenStack Nova project. That's about me. And if you want to connect, that's my LinkedIn QR. Please feel free to scan it. Okay.
Hello, I'm Masanori Kuroha. I'm also software engineer at LY Corporation. I develop and operate large-scale AI system using OpenStack. And recently, I have been trying to contribute to Nova project. Let's move on to today's agenda.
Yeah, thank you. So barely we have 6 different items. We'll start talking about who we are, the problem, the solution, the implementation details, and some challenges and conclusions. So let's get started. Who we are. So we are basically, LY Corporation is a company in Japan and mostly East Asia. So there used to be 2 different companies, Line and Yahoo Japan, which 1.5 years ago got merged. So Line is basically a communication app and Yahoo Japan was a comprehensive internet service, as you can see. So that's basically a very quick background about us. So we care about infrastructure, so let's dive into those details. So Line had its a big private cloud. You can see the numbers here. So that is Verda and Yahoo Japan, and this is OpenStack based, a big large scale private cloud. It's pretty large scale from the numbers you can see. So after the merger, we did not want to manage 2 different clouds, so we planned to create a new private cloud, that's Flava, and we picked on all the positive from both the clouds into this new Flava cloud. These are all the services, and today we care about the server, IS layer server. So we are going to focus on that part. So giving a very brief and simple architecture of Flava. So it's an OpenStack based Flava, which has regional components of hypervisor, bare metal, MySQL, and the global components of Keystone and the UI, of course. So we care about the environments because that is something we need to discuss in this talk today. So we have 3 environments: Flava Test, Flava Dev, and Prod. The test is for the cloud developers, like the people like us and maybe some of you. Flava Dev is for our users, so our company's developers use Flava Dev for developing their services, and Flava Prod is for actually the company's services and products. So these are 3 major environments. And now let's talk about the problem which we are here today. So unused resources. So this is a snapshot of a wardrobe which is like messy, and so you can see it's difficult to manage this. And of course, thanks to that, this is generated by AI. So this is what we want to talk. At the end of the day, we want to have a very clean wardrobe and a simple life. So what creates unused resources? So in terms of VMs, so what creates them is basically human nature is lazy. We usually forgot to delete our test resources. Sometimes after the deprecation of some services, there is a miss and some resources and VMs are left hanging, or there are some automation blind spots wherein the script forgets to clean up. So these items are left hanging and nobody cares about it, and it eventually increases the management cost. So from the numbers, past few years from our actual cloud, so nearly 5% of the VMs were left unused, which boils down to 15K. It's a big number in terms of compute. So what's the impact? Of course, loss. It costs a lot having large resources. And of course, operational overhead. So for people like us who manage and operate a cloud, having more and more of VMs, it's tough for monitoring and maintenance. And security gaps, because since they are left untracked, it could be a vulnerable spot for attacking. So we did try some solutions. So one of which is having some usage surveys and asking the user to please delete them. However, it's not efficient because you need manual work for both users and operators every time. And again, it's not 100%, so that's not a good solution. Another solution was we tried, like we have a dashboard UI and we put a tag about like, oh, this is a low usage server, so please take care about it, either delete it or blah blah blah. But again, it's not a high priority work and people tend to forget it and okay, we'll do it later, and it is still left hanging, so that doesn't really work. So yeah, these old solutions basically it doesn't work. Manually trying to do something, it leads to frustration and no real output at the end of the day. So we have the solution. The solution is VM lifetime. So let's get into the interesting part. So what is lifetime? Basically, user specifies some given grace period of time for which he's going to use the resource VM, and after that period of time, that will be automatically deleted. So basically, you create a VM, you give some usage period. When it reaches expiry, it is automatically triggered for deletion, and finally it's deleted, so the resource is returned. You don't need to do anything, everything will be taken care. You just have to specify the usage period. So that's a very automated solution, of course, and it works. So our target environments are, as I mentioned earlier, it's the test environments. We don't apply it to the actual production, actual products, because that is risky. But we have it all for the development environments. Again, even for development environments, the direct deletion is very risky. So that is not what we do. We give multiple alerts and warnings to the user before deletion. So basically, you create a VM, you reach an expiry, so we don't delete it directly. We shut it down, we give some grace period, and if no action is taken by the user, we then finally delete it. So that's the rough overview. Going into more details, so you can see you set a lifetime, then some alerts are sent, you shut it down, some alerts are sent, then you delete, and in the meantime, if the user extends the lifetime, then there is no problem. But yeah, if you don't, then eventually it will be deleted and you don't need to take care about it, neither the operator nor the user. So there are two main components in terms of design and implementation. So one is the trigger and one is action runner. So you need something which is going to trigger that it is reaching the expiry, or it has already reached the expiry, or what is the time when you need to send the alerts. So that's a trigger, and second item is the action runner, something which will actually do the action, which is either sending the alert or shutting down or deleting the VM. So these are the components which we are going to see for the design approaches. So basically we have roughly three designs, and to quickly explain about it, I think the main is the overview. So inside OpenStack Nova, you can have the trigger and action runner, either both of them are outside of Nova. One is inside of Nova, one is outside, and in design C basically you do everything inside Nova Compute. So for the design A, I think you need to hire a new service, a new lifetime service, because everything is going on outside of Nova, so you need a big service which is going to track everything, and event handler which is going to do the action. In design B, you can do some part of it, the trigger part, inside the Nova Compute, and an event handler for the action. And in design C, you do everything inside Nova. So of course, you can see the pros and cons. The first one is super development heavy as well as very high maintenance. So that's basically something we don't want to do. Between design B and C, you can see like if we do design C, we do not have any record event log. So you will not know who has deleted, was it a user or was it the internal component, which again is not a good idea in terms of troubleshooting or operation. So that is why the winner of course is design B, wherein we do the trigger part inside of Nova Compute and the action outside of Nova. And we also have the logs, and it's not development heavy. So talking about more details, so you can see there are some hypervisors and VMs, and Nova Compute is running on each of the hypervisor, which is our trigger. So at first you are going to update the server metadata based on the lifetime. So when user is going to set the lifetime, the user metadata would be updated based on this lifetime value that the user is going to set. And the Nova compute is going to periodically keep on checking this metadata every day. So the more details will be mentioned later by Kuroha. So we have a periodic checking up for the Nova compute, and based on that you update the metadata. So when you update the metadata, Nova compute emits an instance update notification, so which is then caught by the event handler, which is our action runner. And based on this notification, it will carry out the specified action. Either it could be sending an alert email or shutting down or deleting the VM instance. So that is the brief design, and I hope you understand it and you follow up so far. So for next details, Kuroha will share. Yeah.
Thanks, Nisha. Okay, next let's dive into the technical details of our implementations. This is a simple overflow of the lifetime process. First, Nova compute sends an instance update notification, and event handler receives it, and it performs a required action, such as sending email, stopping instance, deleting instance, or do nothing. Here is a key interface is notification and instance metadata. The instance update notification can be triggered by various events. For example, instance state transition or other metadata update by users. However, the instance update payload does not have the metadata update differences. So as a result, event handler can only get the latest metadata state from the notifications. So we need to define the metadata that allows the Nova compute to communicate the appropriate lifetime action to the event handler, and also metadata design should ensure that the event handler can perform the only correct action whenever a notification arrives. So to realize the lifetime process, we define 3 types of metadata. The first one is key lifetime. As the name suggests, it represents the lifetime of each instance. We selected the year, month, day format for more information than the scalar value like 10 days or 5 days. And this value can be extended by users even after instance creation. Next, the second one is lifetime underscore action. This represents the lifetime action to be executed. The event handler refers to this metadata and take appropriate action. To distinguish multiple email sendings, we included end days information in the value, such as email 3 days or email 1 days. Third, to prevent duplicate execution of actions, we introduced one more metadata which represents when each action is executed. We selected the date time format, and the value is such as lifetime shutdown, lifetime underscore shutdown, or lifetime shutdown, lifetime underscore email, etc. This diagram shows the transition of an instance metadata. At instance creation, the key lifetime, only the key lifetime is set. As lifetime approaches, some running emails are sent. This happens because Nova compute updates the lifetime underscore action key to email underscore 3 days, and the event handler gets notifications and send the email. After that, the event handler sets the lifetime underscore email with the executed date time. On the lifetime date, lifetime action key is changed to shutdown, and lifetime underscore shutdown key is updated. After that, reminder emails are sent. You can see that lifetime action key is changed to email underscore -3 days, and lifetime emails date time is updated. Finally, at the deletion stage, lifetime actions value is changed to delete, and the instance is deleted. So, how does the compute updates instance metadata? We added a periodic task inside Nova Compute. Basically, the task runs every 1 hour, and it gets local instances and calculates the number of days to the lifetime. And Nova Compute updates the lifetime underscore actions metadata due to the days to lifetime. We also made the system resilient to the action failures. For example, when the days to lifetime is 0, update lifetime action function is called. And in that function, Nova Compute checks the shutdown action is already executed or not. It is checked by the lifetime underscore shutdown metadata exists or not. When the lifetime shutdown metadata is missing, the Nova Compute removes the lifetime shutdown metadata and resets the lifetime action metadata to shut down to re-trigger the shutdown actions. Additionally, if the instance is still active even after the lifetime expired, Nova Compute removes the lifetime shutdown key and reset lifetime action metadata again. So this design greatly reduces the chances of lifetime action skipped. Now what's next? Event handler. The event handler's logic is quite straightforward. It receives the instance update notification, and event handler checks the lifetime action metadata and executes the action if necessary. Regarding email sendings, the event handler validates the email sending timing to avoid bothering users and ensuring at most 1 email is sent per day. And one important point of shutdown or delete requests is that the event handler calls the Nova API to shut down instance or delete instance, and Nova's this request is logged in Nova event logs and API's audit logs. So this ensures that we have full traceability of all automated executions. What I've explained so far is the basic implementation of lifetime process. However, this feature only works when the instance metadata lifetime is specified by users. So to ensure that the lifetime feature is used correctly, we implemented several metadata validation in the API itself. First, at instance creation, lifetime metadata is now required field, and user must set the expiration date and value is up to 1 year in the future. After instance creation, metadata lifetime cannot be deleted, and also the lifetime's value is limited. Here the simple CLI shows validation works correctly in two cases, instance creation and instances metadata deletion timing. This validation enforces a lifetime feature. Although the lifetime is now mandatory by metadata validation, we recognize that some instances cannot be deleted or shut down automatically. For example, our IaaS hosts other platform services, and they have their own lifetime mechanism. So, to support these cases, we provided ways to skip the IaaS lifetime. For specific platforms, instances in specific keystone projects and instances with specific tags can be excluded from our IaaS lifetime system. And for end users, users can remove lifetime metadata from their specific instances with proper approval. Basically, the lifetime feature is enforced by default, but it also has a flexibility in certain cases. Next, we'll talk about the adoption of lifetime status and founded challenges. Now, this feature is fully operational in our Flava development environment, which has over 9,000 instances. And currently, more than 1,000 instances have the lifetime metadata. And also about 4,500 instances is managed by other platforms, which have each own lifetime concept. So this means that across the Flava infrastructure, 60% of instances are managed by Flava's lifetime concept. Over the past years, our IaaS lifetime system returned a lot of resources, 4,800 cores and 10,000 gigabytes of RAM and 72 terabytes of disk space. And the event handler automatically deleted almost 1,000 instances, and the users themselves deleted others, likely after receiving the notification email. However, we found that some instances remained not deleted even after the lifetime expired. About 100 instances are unexpectedly undeleted. The majority, about 90 of them, are associated with load balancer. Our cloud has another validation that prevents deletion of instances associated with load balancer. So this deletion failure itself is as expected behavior. And other instances fell into an error state in OpenStack. So for some reason, our compute could not retrieve the instances from your vaults, and the periodic task cannot process them. The results lead to our challenges. For the instances associated with load balancers, also the deletion is expected to be blocked, but there are actually some cases where automatic resource cleanup should be executed, but it is not. To address this issue, we should discuss with LV team in our cloud. We have two options. One is delegating the deletion logic to the LBus own lifetime concept. And second one is establishing a policy that allows us to delete them regardless of the load balancer's status. For the instances with error state, we need to improve our monitoring to detect these deletion failures. Finally, we wrap up the benefits and its contributions to sustainability and key takeaways. The VM lifetime feature brings clear benefits for both users and operators. For users, it means less manual cleanup of unused resources. They no longer have to remember to delete all test VMs. And with lifetime, with features of skipping lifetime or sending reminder emails, they have the flexibility to protect important instances when needed. In addition, by reducing unnecessary or idle resources, we can lower overall costs and make our infrastructure more efficient. In the end, this doesn't just help users, but it also benefits the company as a whole. For operators, we can now reclaim unused compute resources automatically and much faster than before. This improves overall resource efficiency. Beyond the operational and cost benefits, it also has a positive impact on the environment. By reducing the low usage of resource, we can reduce our carbon footprint, and this makes our infrastructure more efficient and more environmental friendly. In conclusion, by implementing our VM lifetime feature, we have automated the tedious work of reduced resource cleanup. We can now focus on the real work and leaving the cleanup to automation. Thank you.
Hi, I have one question. So when you are creating the VM, you are taking the lifespan. So let's say the default is set to 365 days in flavor, and from the user maybe let's say you are taking it for 100 days. But normally, developers tend to have big VMs, keeping it up and running for a longer period of time. But actually, after use of 15-20 days, the VM is completely idle, right? You are not calculating the idle parameter at all.
Yeah, so it depends. So if you want to, we have 30 days, 90 days, 100 days, and 365 days as the VM. So usually, and also 3 days. So if it's a very test VM, usually after 3 days it's automatically deleted, and after 30 days, usually if it's for simple development, the 30 days works out.
Correct. But let's say after 7 days, I'm not doing anything. So between 7 to 30, almost 23 days. Still it's unnecessarily utilizing resources, right?
Yeah, that's
because
correct,
what you are doing is same thing we are also doing, but with the tag resources. So along with the VM creation time, what we are defining for developers, if we'll just include a logic to pick the ideal time as well, then combinedly you can get better throughput.
Yeah, that's a very good improvement.
No, there are a couple of ways.
Have you considered or thought of how this could be implemented more natively in Nova instead of some arbitrary metadata property, like a more first-class citizen property of a virtual machine of the, let's say, life cycle of the resource? Have you thought of that, if it could be implemented as a built-in feature of Nova?
Yeah, that is what we discussed in, I think, one of the design slides.
I thought you were still considering an external action runner.
Yeah, because in our implementation we already have an external action runner, so that wasn't implementation heavy for us. But yeah, it is possible to handle everything in Nova But yeah, that basically requires a lot of development work, and yeah, of course, upstream support as
I
well.
mean, there are a few modifications that we can usually do. I mean, maybe like just emitting the notification without modifying the metadata. Within the notification, you have the flavor, right?
Yeah.
So the action owner can do some policies, and basically you know exactly when the instance was created because we also emitted the notification, right? So I'm wondering exactly why we need to modify specifically some kind of periodic method in Nova, because basically what Nova emits looks to me already enough. I mean, anyone can write a specific action runner only by consuming the notifications bus and then calculating exactly when the instance was created, running the kind of timer on top of that, and eventually until you get any update, then it will then delete the instance. So why actually do you need to add this specific metadata into that? That's basically my question, but maybe you won't have time, so.
Yeah, maybe.
It's something that we are doing in a way, so we can have a type of.
Yeah, I mean, I'm curious about the needs for adding more information to the metadata, to the notification bus, because looks to me we have enough, because you have the flavor. So if you have the flavor, you can define flavor-based policies on life cycle, for example, that then you can add into your runner. So I mean, I don't know. That's yeah.
Let's discuss maybe just after the talk.
You said that the user can decide the lifetime.
Right, at the creation.
And
you can decide.
and don't you go into a problem where a lazy user just put the maximum value? Because that was my user. Like all 999.
So we have a limit of 365 days, and now it's like we cannot really control human nature, so
Okay.
we are putting 365. And if you want to put it to an infinite amount of time, then you need some kind of approval process. So we avoid the infinite time. Thank you.
So the metadata validation you have, is that something that is kind of extensible natively by Nova, or is it really just you had to get deep into the Nova code and sort of add the validations yourself?
Yeah, we added, we deep dived into the Nova code and did some state for the validation.
Do you have statistics on how many instances were shut down and then the user restarted them and extended the lifetime afterwards?
We can calculate it, but we do not have it.
Yeah, but it would be interesting to know if they didn't see the reminders and only noticed when it was shut down that their service was down. And have you considered shelving as well? Shelving instances. So instead of deleting them, you could shelve them. It takes a snapshot and keeps it on glass.
No, we did not consider it. We wanted to return the resource rather than saving the snapshot as well. Because this mostly considered to the cases where you don't need the server at all. I think Thank you.
It's very difficult to automatically remove the project itself because we need to check the existing resources. Yeah, right. So like this is very like manually we are now doing this project because something that all this project itself has been like disappeared for like growth. So even if existing VM, it's okay, please remove it. And completely remove the project itself. This is like manually we are handling now automated. So that's a little bit annoying task.
There are also schedules that all persons already retired on that project, so no one exists a project that still the VM are there, or the device cluster they are there, or resources on
So I'm not sure I'm everything, so I wanted some tip from someone that was doing the same thing.
Yeah, so that and their presentation is just focusing on the VM, so server itself. Well done. Yeah, thanks so much. Maybe last time?
Yeah, that's
Hey, so I didn't understand your use cases because of the presentation. So my point was that, so is it crucial for you that you define the timeout by the user? Is it important for you that that's the user who defines the timeout?
Yes.
Okay, because then the technical decision that you made to use the user metadata, I actually wonder whether it's the good medium for that, because the user metadata is set to be mutable, is set to be modifiable by
This is what we
the
want the metadata protection.
that's what I feel. Based on the presentation, I said, oh, okay, no, I better understand.